A father and a son are using two ends of a rope to pull the stump of a tree from the ground. The father pulls one side with the force of 20 newtons, so this is the father, pulling the tree at a 70-degree angle with the ground. The son, this is the son, pulls the other side with a force of 15 newtons at a 50-degree angle from the ground. And the question is, if the tree stump was to come out, what angle would it come out in, and at what force would it come out? Okay, so in order to solve this, we would be using vectors. So this stump, if they're both pulling on it in different directions, different angles, different forces, which direction would the tree stump come out in, and at how much force would it come out? That's what we're going to be looking at tomorrow. Okay, but just to preview you, and today's going to be specifically. And I forgot to change the number. Sorry. This is supposed to be adding, subtracting, multiplying, and dividing. I think is number 28. Sorry. So this is 28, adding, subtracting, multiplying. Not dividing, sorry, adding, subtracting, multiplying. So we're going to just work on the foundations of how do you add, subtract, multiply vectors in the context of just mathematically, so not in a situation. And then we'll tomorrow look at situations, okay? And for those who are watching this on recording, there was a vote. The vote was that instead of doing the lessons Tuesday and Wednesday, the situations, the word problems, the vote was that we take both of those lessons and do it in one on Tuesday. So just be prepared for a little bit longer lesson and all word problems on Tuesday, okay? All right, so specifically, let's just start with adding vectors. So how do you add vectors together, all right? So there's two different methods that you can do that graphically. The first method is called the head to tail method, okay? The second method is called the parallelogram method, and this is how you add vectors, okay, graphically. So the head to tail method is basically, if you have vector A plus vector B, okay, vector A plus vector B equals what you call a resultant. The resultant vector is vector A plus vector B, okay? So when you add vector A and you add vector B, you get a resultant vector. That's kind of an important vocabulary word. You get a resultant vector. The resultant vector is A plus B, vector A plus B. Visually, what that looks like, using the head to tail method, is if this is vector A right here, okay, you would take A and you would draw it on the graph, starting at the origin. Then if this is vector B, you would take B and you would, this is why it's called head to tail, wherever the tail, which we're considering as the terminal end of vector A, wherever the tail ends for vector A, you would start the head, which we're considering the initial side of vector B. You would start the head of vector B, and then you would continue vector B from the tail of vector A. So you would basically draw A, then you would, wherever it ends, you would start B and continue that on. And then the A plus B resultant vector here, the blue, or A plus B, is from the beginning of A, the initial point of A, to the end of B. That is A plus B, okay? That's using the head to tail method, all right? The parallelogram method is you start both of them at the same place. So you start vector A at the same place and you draw it here, A. Then you start B at the same place and you draw vector B. And then what you do with these two, let me do a different color actually. You can see the difference. So we do this as vector A, we do this as vector B. And then basically you create a parallelogram, okay? So if this is B, a parallelogram meaning there would be another, on the opposite side, there would be a B. So that's parallel. And then vector A that we have here, we would draw that parallel on the opposite side. And then you create a parallelogram, and the resultant is the diagonal of that parallelogram. So this is A plus B. So those are the two methods visually, okay, or graphically. So head to tail method and parallelogram method. Both of which, if you look at it, A plus B is in the exact same position, right? The resultant is the same. Algebraically, if this is one vector and this is the other vector and you're adding them, you really just add x1 and x2. That becomes your A of your resultant. you add y2 and y1 and y2, that becomes your b of the resultant. Okay, so that's algebraically. So let's look at an example, and it'll make a little bit more sense if that was confusing for you. So this question says, what is the graph of the resultant of the two vectors a and b? So if it's asking for the graph of the resultant is a plus b. Okay, so we're going to try the two methods. So over here, I'm going to do a head to tail method. And over here, I'm going to do the parallelogram method. Okay. So if we're using the head to tail method, we're going to start by graphing a 2, 1. So the a is 2, the horizontal component is 2, the b is 1, the vertical component. So for a, I'm going to go to the right 2 because it's positive. And we're going to go up 1. And so vector a is this. That's vector a. I'm going to erase this so it doesn't get in the way. So that's vector a. Okay. And because we're using the head to tail method, when we draw vector b, we're going to continue it from the end of vector a. So vector a ended here, so we're going to go to the left 3 because a is -3, so the horizontal component of the vector is -3. 1, 2, 3, so to the left 3. Let me actually do that, dashed. And then we're going to go up 4. 1, 2, 3, 4. And that will be vector b. I probably should have made that graph bigger, sorry. Erase this. Okay. So we started with a, we drew a from the origin, then we drew b from the end of vector a, and the resultant vector a plus b is when you start from the beginning of a and you go to where b ended. That is our resultant vector a plus b. Okay. And so that a plus b as a vector, this is vector a plus b, the resultant, we see that it goes to the left 1, so the horizontal component of that is -1, and it goes up 1, 2, 3, 4. So -1 comma 4 is a plus b. Okay. Any questions thus far? All right, let's try the parallelogram method. So parallelogram method, we're gonna graph both a and b from the same starting place. So we already know a is over 2 up 1, so it's like that. That's a. B is left 3 up 4. But we're gonna now start it from the same starting place as a, so the origin. So left 3 and up 4. Okay. So now the parallelogram method would be that we would take this and we would create a parallelogram from it. So if this is a over here, we would have a one on the opposite side that is parallel to it, and it would have to have the same exact measure. So if this one went over 2 and up 1, we're going to be over here and going over 2 and up 1. So it'd be like this, be a on the other side, parallel. Okay. And it would be the same thing for b. If we have b over here, we would do parallel on the other side to create a parallelogram. And that went left 3 and up 4. So from here, we would go left 3 and up 4. It's going to end up connecting with that one. And the resultant vector of a plus b is when you go from the initial side of both of them to the opposite diagonal that is created to the opposite side. And that would be A plus B. If you look at A plus B, it's the exact same as the head to tail method. It is to the left 1, -1, and up 4. So they are equivalent, just two different ways of doing it, okay? Now, algebraically, which is kind of the simpler way, you could just add them. So like if you're doing A plus B, you literally would add A plus B. So this is A, and this is A. If you add 2 plus -3, it gives you -1, right? And this is 1, and this is 4. If you add 1, I did something wrong. That would be 5, right? So actually, let's rewind it back for a second. Sorry. Over here, it looks like it went up 5, not 4 then, right? Right here. This is up. Something's wrong. Hold on. Give me 1 second. 2, 1, -3, 4. Yeah.
I think it is up 5. It's just
Yeah.
that your line, it's hard to see.
Yeah. This is up 5. My bad. This is left 1, and this is up 5. So this should be 5 here. And this one is left, also left 1 and up 5. My bad. All right. So I couldn't see the graph, my bad. So it's up 5, -1, 5, because these have to all match. All right. Hopefully I didn't confuse anyone. Any questions thus far? So we're talking about how to add using head to tail method, parallelogram method, and just algebraically how to add. No? Okay. So and then if you would graph -1, 5, it would go left 1 and it will go up 5. This would be A plus B. And so you should see that that's going to be the same. Like this resultant vector A plus B is the same as this one and this one. So kind of any way that you do it, that's what you're going to get when you add them. Okay. So pretty straightforward, pretty simple, just how to add them. Okay, we're just looking at mathematically. So let's say we want to add A plus B plus C. You can do the same thing with 3. So you could graph these 3. Like you could do, okay, I'm going to do -2, 4. I'm going to add this one on B, 4, 3. Then I'm going to add this one on C, 1, 0. And then the resultant is going to be like from here to here. That would work. You could do it with 3. You could do it with 4. You do it with 5. It's going to end up with the same thing. Or you could just look at it and you can see, okay, A plus B plus C. So you can just add -2, 4, and 1. So that would be 3. And you can add 4, 3, and 0, and that would be 7. So 3, 7 would be what you get if you were to do it this way. So either way would work. You could do the head to tail method, or you could add it. Okay. All right, so that's adding vectors. Let's talk about multiplying. So for multiplying vectors, when you multiply by a constant out front, like k in this case, and let's say your vector is a and b, it's kind of like distributing. You multiply it times both of them that are inside, so the a and the b, okay? And this k is called the scalar, okay? So this 2 is called the scalar. It's how much is being increased by, all right? So let's try this. So let's say we graph vector v 3, 2. I really should have made these graphs bigger. 3, 2. That's vector v. Yeah. And we multiplied vector v by a scalar of 2. So 2 times v. Then it would be 2. Oh, sorry. Times 3, 2, which is vector v. So you would go ahead and you would multiply. You can think about it as distributing. You wouldn't necessarily call it distributing, but you can think about it as distributing we're multiplying 2 times A and 2 times B. So that'll be 6 and 4. So this is your new vector, 6 comma 4. So you're going right 6, that's your horizontal component, and up 4, that's your vertical component. So this would be the vector 2v. Yeah. Really all that's doing there is if you're multiplying by 2, then that's just adding another one onto this. So if this went over 3 and 2, it would just be adding another one over 3 and up 2, right? So it's like 2 v's. Because these two will end up becoming that, 2 v's. Or v plus v is the same thing as 2v, right? So that's kind of what we're doing there. Now for negative v, similar concept. You have, except you have negative and then 3 and 2. So we would be distributing the negative or multiplying by -1. So that would be -3 and -2. -3 and -2. And so there, it's going to be going left 3 now and down 2. -3 and -2. That's our horizontal and our vertical component. So our vector negative v is this. That's negative v. And so what happens when we put a negative here is what happened to the vector? It changed what? And anyone can answer. It changed what? What changed when we added a negative using our vocabulary about vectors that we know?
Change direction.
Okay, very good. It changed the direction. So when you added a negative, it changed the direction. It went from going kind of northeast or up and to the right to down and to the left. When we multiplied by a scalar of 2, that changed the what? When I multiplied by a scalar,
Magnitude.
That changed the magnitude because the distance increased, right? When you multiply by a half, let's see, that'll be a half times 3 comma 2. It would distribute the half. It would be 3 over 2 comma half times 2 is 1. So now 3 over 2 would be your horizontal component. That's going to the right 1.5 and then up 1. So that would be what it looks like. So in this case, we also changed the magnitude. In this case, it went down. In this case, the magnitude went up. Okay. So that's how you multiply vectors. Let me pause and see if there are any questions up to that point on adding, multiplying vectors. This is just algebraically. We're not doing situations yet. I want to make sure we get the foundational concept of kind of how they work first. We good? All right. So let's try that. That's actually pretty much the lesson for today. We're just going to do 2 more problems just algebraically. This is just a foundational lesson to set us up on the algebra. So we're just going to do this one together, and I'm going to give you one to do on your own. And then that's it for today. It's a shorter lesson, all right? So let's say we have these vectors. We have vector w, we have vector y, and we have vector z. And we're trying to do z minus 2y, okay? So vector z is -3 comma 0. Minus 2, vector y is 2 comma 5. So we're not using vector w in this problem. It's just given to us, but it's not, we don't need it for this one. So we're doing -3 comma 0 minus 2 times 2 comma 5. Okay, so first we would be using the PEMDAS order of operations, so you'd have to multiply first. You would multiply the -2 times the 2, it's going to be -4. -2 times the 5 would be -10. And if you dealt with that negative by distributing it, then what goes right here now is not another negative, right? Because if you put a negative here, then when you distribute it, it's going to become +4. So we already distributed this negative into it. So now what we put here is just an addition to represent that we're combining. I'll say that again. If you distribute the negative at the beginning, then you dealt with the negative already. You would just put a plus sign here, okay? If you chose to only distribute the 2 only, then you could keep the negative here, okay? But I think it's easier if you distribute the negative with it, change that to plus, and bring down -3 comma 0, okay? And then when we're adding, we would just add this and this, the A and the A, it would be -7. And we would add the B, 0 and -10, that would be -10. And so Z minus 2Y is that. That's it. Okay. Questions? All right. Just to make sure we understand it fully, I want you to try this problem. Okay. So I'll give you a few minutes to try it. When you're done, send me a private chat message so that everyone doesn't see what answer you got of which one you get. Okay. So I'll give you a minute to work on this. And all of y'all got it right. Very good. The answer was D. Okay. All right. Awesome. So that's the lesson for today is just adding, subtracting, and multiplying vectors. Again, just to set us up for tomorrow, which is going to be on situations. The practice, which is due on Thursday, is IXL. Okay. These are easier ones. These you can finish some of these in like 5 minutes. So it's U5, U6, U7, U8, and U10. And you would do them similarly. You would take a picture of the your grade, and then you would upload it into Google Classroom. And if you could do the average of these, so like if you get 90, 85, 90, 100, and then 80, okay, you would average these as the original grade, like whatever the average. Like let's say the average of these is a 92. You would type that in the private comment section, so that I'm able to see that. And then I just kind of look at the averages, make sure they make sense. But it helps me out with grading since I don't have a TA. And so you would just send a screenshot, and then in the private comment, you would do the average. I haven't decided yet if I'm gonna do a curve for this one or not yet. So for now, just type the regular average, and I'll think about later if I want to do a curve for this one. Okay.